Welcome to Algebra 2 10.6 video lesson. Today we're going to learn about how to translate conic sections. And there's a lot of information on this slide right here, but you have most of it already. And we've done a lot of really hard work to get to this point. So first I'm going to talk about the ellipse and how to translate the ellipse. Okay, we should have this formula down, the one with the little star next to it. That's with an ellipse that is a left-right ellipse centered at 0, 0. And we want to translate it to a left-right ellipse that's centered at a different location, h, k. So that means that our center is no longer going to be at the origin over here. It's going to be moved somewhere h and k. The important thing to remember is that the h always goes with the x and the k always goes with the y. Okay. The reason I know this is a left-right is because the a squared is underneath the x variable. So therefore, it's going to be a left-right ellipse. Now, if I want an up-down ellipse, we've already known this one. The a squared is going to be underneath the y squared. If I translate this to a center that's at h, k, the only difference is the little highlighted part there. I have an h and I have a k. And remember that the h always goes with x and the k always goes with y. And your picture would look something like this, like an up-down ellipse. Okay, I'm going to give you a minute to copy all this down. But this is basically what we're doing for this video lesson. Okay, here's box 2. We're going to do an example together. So take a look at this equation. I've got x minus 3 squared over 64 plus y minus 5 squared over 36. So I'm going to ask you a couple of questions about this particular ellipse, and then we'll graph this one together. Okay, so hopefully you've already should have figured out that the center of this is at the point 3, 5. So the first thing we're going to want to do is put the center at 3, 5. So there is my center, and I'll put a little tiny c for center. Okay, is this going to be an up-down or a left-right ellipse? And the answer is this is going to be a left-right because of the two denominators, 64 is bigger than 36, and it's underneath the x. So therefore, I know that a squared is equal to 64. Therefore, a is plus or minus 8. So what that means is from the center, I count 8 left or right because this is a left-right ellipse. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. Put a dot there. That's one of my vertices. And then go left. 1, 2, 3, 4, 5, 6, 7, 8. There's my other vertex. I'll call it vertex number 2. And then I also know that b squared is equal to 36. So therefore, b is plus or minus 6. So from the center, we go up and down 6 units. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, and 6. And that's really enough information to sketch this ellipse here. And this is what we would expect you to be able to do. The only other thing that we would need is the location of the focal points, which we know that c squared is equal to a squared minus the b squared. So if you had to figure that out, you could. But the focal points would be somewhere in this region and somewhere in that region. But since it just said graph the ellipse, this is what you got to work with here. So hopefully that makes sense to you. Okay, box number 3 is all about the hyperbola. It's going to be the same concept here. We should already be good with this equation, a left-right hyperbola. The reason this is a left-right hyperbola is because the a squared is the positive one, and it's underneath the x squared, so now it's left-right. So we're just going to translate this to a center somewhere other than h and k. It's exactly like the ellipse. The only difference is the sign in the middle is a negative. Same thing with the up-down. This is an up-down hyperbola because the a squared is underneath the positive one, which is a y squared, and y's go up and down. So similarly, when I transform this into an up-down hyperbola, the a squared is still going to be underneath the y, and I've got an h and a k. So I'll give you a minute to copy that down if you need to. Okay, box 4 is going to be an example. We're going to graph y minus 1 squared over 25 minus x minus 3 squared over 36 is equal to 1. So right away, we know this is going to be a hyperbola, and we also know that this is going to be an up-down hyperbola because the 25 is the positive number of the denominators here, and it's underneath the y, and y's go up and down. That's how you can remember it. So the center is still h, k. And the h is with x's and the k is with the y variables. So the center is going to be at 3, 1. So let me do that in like a cool red color for you here. So 3, 1, and then we'll graph that. So 3, 1 is my center. There it is right there. And I know that the a squared value is equal to 25, so I'll write that down. So a squared is 25, so therefore a is equal to plus or minus 5. So remember, it's up and down, so I'm going to go 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, and then 5. Okay? B squared is 36, so therefore b is equal to plus or minus 6. So from the center, we'll go out 1, 2, 3, 4, 5, 6, put a point, and then 1, 2, 3, 4, 5, 6, and put a point. Now that's enough to draw your box that gives you the shape of the hyperbola here. Okay? So there's my box right there. So remember that this distance is our A distance, and this distance right here is our B distance. Okay? So our slope of this thing is going to be A over B. All right? So we're going to keep that in mind. One vertex is here, and that's located at 3, 6. So I'll do 3, 6 is one vertex. The other vertex is down here, so I'll do V1 and V2. So that'd be 3, negative 4. 3, negative 4. And then ask me where the focal points are. And I know that C squared is equal to A squared plus the B squared, because I'm dealing with a hyperbola in this case. So therefore, C squared is going to be 25 plus 36. So therefore, C squared is going to be, so 25 and 36 make 61. Okay, and then when I take the square root, see with the square root of 61, I get about 7.81. So that's going to come in handy because I know one of the focal points is about 7.81 units above the center. So from my center, I count up 1, 2, 3, 4, 5, 6, 7, and then a little bit more. So that's one focal point. And then down 1, 2, 3, 4, 5, 6, 7, and then a little bit more. That's another focal point. So that's important because it's going to help me draw the picture in just a second here. So the asymptotes are the lines that go through the corners of the box and through the center. All right, so there's that one. And then there's this one here that go through the corners of the box and the center. Okay, so the easy way to get the equation for the asymptotes, in this case, because it used to just be y is going to equal a over bx, whatever that is. That's if our graph was at the center. But it's not, it's at somewhere else. So we're going to say this, so y minus 1 is equal to the a value, which in this case is 5, the b value, which in this case is 6, and then an x minus 3. So we're just simply moving and shifting the things around to get the equation for the asymptotes. So one of them is y minus 1 equals positive 5, 6, x minus 3, and then the negative of that. So the way you can represent the asymptotes is y minus 1 is equal to plus or minus 5/6 times an x minus a 3. That's kind of challenging, and we can definitely touch on that tomorrow in class. But here's a cool way to represent the focal points. It is rad 61 units above the center, and my center is at 3, 1. So what you could do is you could say it's over 3 up, 1 plus or minus rad 61. And that's a cool way to represent the location of the focal points. Anyways, when you're all said and done with this, you've earned the right to start at a vertex, trace out your hyperbola, start at a vertex, trace out, and mirror the asymptote. Start at the vertex, trace down, mirror the asymptote. Start at the vertex, trace down, and mirror the asymptote. So that right there is a full sketch of how you would do something like this. And we have to be responsible for center, vertices, foci, and asymptotes. Okay, box 5 is how to identify a translated conic that looks nothing like the standard form like in the other boxes here. So here's what we're going to do. We're going to group all of our x terms together. So we're going to group 4x squared minus 24x, and then group your y terms, plus y squared minus 6y, and then I have my plus 9 equals 0. Sorry, this pen looks as like multiple colors. It's kind of tripping me out, so I'm going to go back to like a green pen. Okay, so I'm going to do 4x squared minus 24x plus y squared minus 6y plus 9 equals 0. Okay, what we want to do is we want to factor out any leading coefficients that aren't a 1. So like I could take out a 4, and that will leave me with an x squared minus 6x plus something. So leave some space here because we're going to create the magic number here. The leading coefficient on the y squared is a 1, so I can just keep that the same. So I've got a y squared minus a 6y plus something. So it's going to be a magic number. We're going to fill it in just a second. Is equal to, move your constant over, -9 plus the first something plus the second something. So now all we do is figure out what goes in these boxes. So half of -6 is -3. Squared is the number 9. So don't forget to multiply 4 times 9 to get that factor over here to give you 36. Okay? The number that goes in here is also the number 9. But since I'm just multiplying a 9 with a 9, I just get 9 over there. So what we have here is this piece becomes a perfect square trinomial, and it will always factor down to x minus half of your b quantity squared. So it's going to be 4 times x minus 3 all squared. This is a perfect square trinomial, which is going to be the quantity of y minus 3 all squared. Then on the other side, you can see the 9's cancel out, and I get 36. So I'm going to move this up just a little bit. I'm going to divide both sides by 36, divide by 36, divide by 36. And so when I'm all said and done, I get 4 over 36 reduces to a 9th. So I get x minus 3 squared over 9 plus y minus 3 squared over 36 is equal to 1. And from here, we should be able to identify this conic section. This is an ellipse because I have a plus sign in the middle. The bigger number of the two is the 36, which is underneath the y, so that tells me it's an up-down ellipse. And the center is going to be at 3, 3. So that's how we can do all this together. It's called completing the square on each term. Okay, in box number 5, I'm going to show you how to identify a conic that's been translated that looks nothing like what we've been working with before. So the trick here is we're going to complete the square on both the x and the y simultaneously at once. So you want to combine your x terms, so 4x squared minus 24x. Then combine your y terms, plus y squared plus 6y plus a 9 is equal to 0. Then we want to think about grouping our x's and grouping our y's and moving our constant over. I can see that my leading coefficient on x squared is a 4, so I'm going to factor out my 4. That's going to give me with x squared minus 6x plus, and then I'm going to leave some space here to fill that in to make a perfect square trinomial. Then over here, I don't have to worry about factoring out anything because the leading coefficient is a 1 on the y squared term. So I'm just going to get y squared plus 6y plus something. And then is equal to, I'm going to move that constant over, -9, plus the first something plus the second something. So now I've got to figure out what goes in here. Well, this is the normal way we do it. -6 divided by 2 is our -3, and then we square that and we get 9. And then same thing here, 9's going to go there because half of 6 is 3, 3 squared is 9. But then don't forget this, I am factoring out a factor of 4 times 9, so I need to bounce that over to get the number 36. And then this one just goes over the other side because I'm only factoring out 1 factor of 9, not 4 factors of 9. Okay, so this becomes your perfect square trinomial, and it's going to be 4 times the quantity x minus 3 squared. This is a perfect square trinomial, and it's going to be y plus 3 quantity squared. Then on the other side, the 9's cancel, and you're left with 36. The only thing left to do is divide each one by 36, and the answer is going to be staring at you. So 4 over 36 reduces to a 9th, so I'm going to get x minus 3 quantity squared over 9, plus y plus 3 quantity squared over 36 is equal to 1. So from here, now that it's in this form, we can see it's going to be an ellipse. And of the two denominators, since I'm working with the ellipse, the 36 is larger, so it's going to be underneath the y variable, so that means it's an up-down. The center is going to be at 3, -3. A squared is worth 36, b squared is worth 9, and if you had to, you could probably graph all of that. So that's how you identify a conic not written in this section. You're going to have to do one right now on your own. Okay, here is your you try, box number 6. Tell me what conic section this is, and then tell me everything you can about it. There'll be a lot of questions about this one. Okay, hopefully you got all of the right answers, but if not, here is the solution. So the first thing I did was I grouped my terms together. Then I made a perfect square trinomial in the x's. I factored out a 4, made a perfect square trinomial in the y's. Moved the 7, or the 7 was already over there, moved the 1 over, and then bounced over a -4 because -4 times the 1 gave me that -4. Then I got the x minus 1 quantity squared over, oh, sorry, not over that yet, minus the 4 times the quantity of y plus 1 squared is 4. Then I just divided by 4 everywhere, and I got the final answer. So hopefully you got that this is a hyperbola. This is a left-right hyperbola. Hopefully you realize the center is at 1, -1, and the value of a squared is equal to 4.